Okay, paper 1-1. This is the one. Right. Very good. Cool.
Assalamu alaikum, sir.
Walaikum assalam. How are you, my friend?
Alhamdulillah, sir. How are you?
I'm good too.
Sir, by the way, if you remember, we did this paper.
We did?
Yeah, we've done this paper already.
If we have done it. Oh, yes, we have done it already. Oh, no. That's not fair. Can we do October, November 2-3 then? 1-3. 1-3 would be.
1-3.
Yeah, 1-3.
I don't know. Okay.
Okay, let's do this.
Can we do 1-2, sir, or have we done?
We haven't done 1-2 as well?
I don't know, man. I don't know.
Okay.
No, not October, November. Not 2020 papers. Can we do a 2019 paper?
2019. Yeah, we can do that. Okay, why not? But you guys then have to solve this on your own, okay?
Yes.
Because the issue is November. Just a second, alright? Just a second. So I would want you to basically wait a second. November 2000 and wait a second. That's 19. We got to do 19. Okay, and 2019. Okay. Okay, so let's start from 1-1, okay? I think it should work, and then let's move forward. Okay, that's pretty good. All right then. Just give me like one.
So should we do it on our own now?
No. I'll solve it. What you do is you do it later. Like once you're done, when we're done, you can solve it on your own, and you can check if you can still manage to do it. What do you say?
Always. Yeah, that's fine.
Yeah, that's better
That's
actually.
fine.
Yeah, that's better. Okay, so so let's start. So which quantity is the magnitude reasonable estimate? Right. Okay, so which quantity is magnitude reasonable estimate? Radio frequency of radio hertz. What? That's 500 pico is 10 raised to minus 12, which makes it 5 into 10 raised to minus 10. That's not the frequency of radio wave for sure. Okay, and then mass of an atom, 500 microgram. What? This is too big. That's not true. Young's modulus of a metal. Young's modulus is generally into 10 raised to power 9, 11 like that, but that's too small. Wavelength of green light, that is correct. Wavelength of green light is exactly 500 nanometer. Okay, pretty good. Now let's go forward. The speed of the wave in deep wave depends on its wavelength and depends on its wavelength and acceleration of fall. What is the possible equation of speed v? Okay. So wavelength in deep water depends on wavelength. The speed of wave in deep water depends on wavelength acceleration of free fall. Which is the possible equation of the speed of the wave? Interesting. So v equals to f lambda, and then what you do is, right, and then we have to somehow include g as well. Why would it say acceleration of free fall in deep water wave? Interesting. I would not check it like this. I think that's not fair. I'll do what? Because I don't know which equation they're referring to. So the best technique is that you check which of these has consistent units with velocity. And if we get the same base units, then the equation should be correct actually. Okay. So g will be meters per second square and length will be meters. So it is meter square second square under root, which is basically meters per second. Okay, pretty good. So this means it has to be a, but we'll check. This is meters, meter square second square. So that's wrong. That's not the same units as v. This is g upon l. That is meter per second square over meter. So 1 upon second square under root is second. So that's not also correct. Okay, and then v equals to 2gl. That's also the same equation. So the base units doesn't, they're not same. So that's why we are choosing a, because it gives me the right base units for velocity. Then which diagram best represents vector z? So what you do, it says x equals to y plus z, and we want to find z. So make z the subject of the equation. That would make y minus x, right? So y would stay the same, but minus x would be in the opposite direction. So I'm just going to make that, and then this will be y, and this will be minus x. This means that this is going to be, I think here, resultant will be like this, right? So which that's a. Okay. Okay, so then the student tends to measure accurately the diameter of wire known to be approximately 1 millimeter, the internal diameter of pipe known to be approximately 2. What are the most appropriate instruments for this to use? Okay, so for this small, wires are usually done by micrometers, and thickness or the internal diameter is done by calipers. So it has to be C then. Then 5. Where V is the potential difference, the percentage uncertainty in V is 5 and R is 2. What is the uncertainty in P? So delta P over P is equal to delta V over V plus delta R over R. Because there is a square here, so we're going to multiply 2 here. So the percentage of V is 5% and R is 2%, which means 10% plus 2% is 12%. So it has to be D then. Pretty good actually. All right, and then the velocity time graph of an object of mass 2.5 kg is shown. What is the resultant force acting on the object? Whoa. Okay. So first of all, we'll find the acceleration, which is basically seems 3 and 12. So 12 minus 3 divided by 15. That's the time. So where's my calculator? Hold on. So that would be 9 divided by 15, which is 0.6 meters per second square. And then F equals to ma, which is 2.5 is the mass. This is 0.6. So 2.5 times 2.5 times 0.6 is 1.5 newtons. That would be C actually. This paper doesn't seem that difficult to me for some reason. Okay, then going to which statement follows directly from Newton's first law? Okay, so the body remains at constant velocity unless acted on by resultant force. That is correct. The circular motion about Earth has constant velocity. That's nothing to do with this. The water drop leaving a spinning umbrella travels at constant velocity. Nope. The force acting on an object is equal to change in momentum. That is basically first it should be the resultant force, and this is the second law. The resultant force causes an object to accelerate, what is equal to resultant force. So resultant force, the acceleration Resultant force is mass times A. So acceleration per unit mass is wrong. The change in kinetic energy of object per unit time. What? Nope. The change in momentum per unit time, that is correct. That's the definition of resultant force, by the way. Then the skydiver falls from aircraft that is moving horizontally. So it means if his initial velocity will be the same as the aircraft velocity. The vertical component of velocity of skydiver is v. The vertical component of is v. Okay. The vertical component of acceleration of diver is a. Okay. Which row describes v and first few seconds? So first of all, I should say that as he falls, then his speed vertically would increase, and then acceleration would basically has to decrease because there's air resistance, right? So it has to be d then. Okay, my friends. Now two gliders are traveling towards each other on a horizontal air track. Glider P has this kg and moving this glider. Okay, fine. So they have perfectly elastic collision. What are the speeds of two gliders? So first of all, I would use u1 plus v1 equals to u2 plus v2, and then you don't have to worry about anything. So let's take this side as positive, let's take this side as negative. The gliders have perfectly elastic collisions, but have they told that when they collide there's something else happens? I don't know, and they haven't given this, right? Interesting. Okay, let's see then. So u1 is 1.2, u2 is minus 1.8, and then it should give me v1 is plus 1.2. I'm just taking plus, I don't know why am I doing this, but I shouldn't do this actually. I shouldn't do this because its momentum would be much larger than this. They should move in this direction, something like that. Interesting. So minus, I would take minus this, and I would take v1 to be also minus 0.6. I don't think so these answers are equal, so that's not the right answer. So 1.2 plus minus 2, and okay, and this is minus 1.8 plus minus 1.4. So this will be 1. It will be 1, basically 2.8. This will be 1. That is not the right answer. Now 1.2 and plus minus 2.8, and this will be minus 1.8 plus minus 0.2. So this is going to be basically, what is 2.8? 1.2 minus 2.8 is 4. Sorry, minus 2.8 is 4, and yeah, that could be opposite. So if this is like it goes in the opposite direction, if I take this as positive, then I can see that the total here would be actually minus 1.2 as well. So minus 1.2 minus 1.2 has to be C. So you have to check basically that where your answers. Give me a second, please. Alright. So you gotta check which answers on both sides are correct of the equation of relative velocities, right? So if both are correct, this means both are equal on each side. It means this is a perfectly elastic collision. By the way, I hope you guys understand this, alright? Now, going to the next question. Okay, so the next question basically is 11 and says what is the ratio of density of oil and density of water? Right, density of oil and density of water. So you have Q, which is much less than this and much this. Okay, so the upthrust, so the weight of the water will be mg, the upthrust will be rho g delta v. Here this is same mg, rho g upthrust is rho g delta v. Okay, and then there is tension. Here you have also the tension. So here tension is equal to P, there it is Q. Okay, so what you do then? So we can make an equation. We could say tension or P plus rho G density of water times delta H is equal to mg, and then on the other side we can make Q plus density of oil times G times delta V equals to mg as well. Now because mg and mg is equal, so we can put P rho Wg delta H equals to Q plus rho oil times G times delta V. Oh, sorry, delta V. So now in this equation, what do we do then? Interesting. We need to find the densities. We need to find the densities, right? And W is the weight, I think. And the weight be there in the equation. There is weight as well. We can't really substitute it. Sorry, I should have written weight here. W and W. I have to make the equation again. Sorry. So okay. So P plus rho of water times G times delta V is equal to W. Fine. And here Q plus rho W, rho naught, G times delta V is equal to W. Right. Now what we're going to do is we are going to make this section the subject of the equation. So this will be rho W G delta V equals to W minus P, and that will be rho O times G times delta V equals to W minus Q. And then what you do, you can simply divide these two equations together. This will cancel. So density of water, density of oil will be W minus P over W minus Q, but we need the reciprocal of it because oil is on the top, so it will be W minus Q over W minus P. Is there an answer like that? W minus Q, W minus P, that's D. Okay, now sorry. And then which diagram shows a couple? So couple has to be two opposite forces. The only couple is A, pretty much the same. Now here, what is the tension in the left hand string? Okay, so this would we'll make two components here. We'll make okay, so this will be T1 sine 70 okay, let's call this T2. Okay, and this will be this will be T1 sine 70, this will be T2 sine 20, this will be T1 sine cos 70, and this will be T2 cos 20. Okay, now this is pretty awesome. Let's try to do it. So T1 sine 70 plus T2 sine 20 should be equal to 120 because these are collinear, and then T2 cos 20 should be equal to T1 cos 70. So we want to find T1, so we have to replace T2. So T2, this is first equation, this is second equation. So T2 will be equal to T1 cos 70 over cos of 20. And now plug it back. So T1 sine 70 plus T1 cos 70. So I'm replacing this T2, okay, divided by cos 20 times sine 20 because it was there equals to 120. Now we can solve this. Wow, sine 70 plus cos 70 divided by cos 20 and then times sine 20. That would be, yeah, this one. And then T1 times 1.064. So T1 will be 120 divided by 1.064. So 120 divided by 1.064 is 112. 112 point something, which is basically 113. So you got to do this, okay? All right, and then what you do? 14. A large container of oil refinery, 3 oils of different densities are mixed, and oh my god. Okay. The mixture consists of this. What is the density of the mixture? Okay. So first of all, I would like to find the volume of this, because when combined density, you have to add all the masses together, all the volumes together, then you can find. You can't just take average directly, okay? So density is mass over volume, which means that volume will be mass over density. Okay, so for the first one, the volume is gonna be 1200 divided by 1100. So that is 1.091. The second one is going to be 1500 divided by 860. That's 1.744. And the third one, which is V, has to be 4000 divided by 910. So that's 4.396. Okay, so now you add all the masses together. So 1200 plus 1500 plus 4000. This will be 6700 divided by all the volumes. 1.091 plus 1.744 plus 4.396. So that is 7.231. What? Yeah, okay. So 6700 divided by 7.231 has to be 926, which is A. Okay. So make sure you always follow the rule that the combined density is total mass over total volume. It's not basically, don't average it. Averaging is wrong. It will give you a wrong answer. An electric motor produces 120 useful mechanical output power. Efficiency motor is 60%. So what is the input? So 120 divided by 0.60 would actually give us the input, because wait. Okay, so 120 divided by 0.6 is 200, so it should be 200, and wastage of power would be 200 minus 120, that's 80. So D. This is pretty easy. And now let's do this one. During the change in work done by gas surrounding, how much work is done on the gas? So the work is done on the gas when the pressure is constant. Okay, so at here the pressure is constant, at here the pressure is constant. Okay, so in two changes, the work is done by or on the gas. In one change, work is done on the gas. So okay, now when work is done on the gas by its surrounding, so suppose the gas was like in a balloon or something, so you compress it, so the volume should decrease, right? In this particular change, the volume is decreasing. All right, so what are we going to do? We know that at this the pressure is this. So work done is pressure times change in volume. Pressure is 1.0 times 10 raised to 5, and the change in volume is basically 5 minus 2. times 10 raised to power minus 4. Okay, so let's now do it. 1.0 times 10 raised to power 5 times 3 times 10 raised to power minus 4. So that has to be 30 joules. Okay, 16 is 30, right? If you have any questions, please do let me know, okay? Okay, sorry, now it will be visible to you. I don't know how I moved this, but it did move some reason. Okay, now an object is traveling with a speed of 10 meters per second, has a kinetic energy of this. The object speed, the speed of object increased to 40. What is the new kinetic energy of the object? All right. So basically, interesting. The change in kinetic energy will be half mv square minus half mu square. So this will be in fact, this is not that simple. Let me think about it. So 500 joules was when it had basically 10 meters per second square, which is basically equal to 500 times 2, and then
Sir, it's 1500.
it's 1500. Oh my god, I made a terrible mistake, sorry. Times 2 divided by 10 squared. So it is the mass is basically 30 kg. Now now we can find the change in kinetic energy. So half mv square minus half mu square. So this will be half times 30 times 40 square minus half times 30 times 10 square. So let's find the change in increase in energy, and then we'll add it to the previous one. So 0.5 times 30, and then we can just take it common just to make it faster, okay? Minus 10 square. Okay, so this gave me the new kinetic energy. The change in this is this, right? So this is the change in kinetic energy, the increase. So initially it had this, so we're going to add that. So it's 24,000 actually. Okay, so this was question 11 and 12 and 13, 14, 15, 16, 17, and this is where we are right now. Okay, the engine of a car exerts a force of 600 newtons in moving car 1 kilometer in 50. Okay, what is the average useful power output? Okay, so first of all, work done is force times displacement, and divided by time gives us the power. Okay, so force is 600, the displacement is 1000 meters divided by 150. I think this is easy. 600 times 1000 divided by 150, so that is 4 kilowatt. Okay, right, now going to the next one. What is the spring constant of the spring? So F equals to kx. The force here is 6. K we want to find. The x is in meters. So 15 times 10 raised to minus 2. Okay. So 6 divided by 15 divided by 10 raised to minus 2 gives you 40. Now wire extended shows extension of wire varies with force applied. Initially, the force W gives an extension of D. The force then increased 2W, the increase in extension 2D. Which area of the graph represents work done by force when the force increases from W to 2W? Okay, interesting. So the area should always be taken from like under the force graph. So it is basically this much. This is the increase, right? So this would be TMRS. TMRS. Okay, that's correct. Okay. Now let's go to the next one. It says 21. The transverse wave on the rope is time period this. The particle is labeled at x. Which graph shows the variation displacement of x with time period? So this is the direction of travel. So the next, like this wave is gonna look like this next, right? And then it's going to look like this next. So basically what is happening, x will go down, x will go up, then x will go up, and x will go down. So this is basically how it is gonna be, right? So which graph represents it? So x first goes down, x first goes, okay, this is wrong entirely because it doesn't start from 0, it's already at 0. So I mean it should start from like from 0, it should go down actually. So it's not going down in either of these. So this is wrong, this is wrong, this is wrong. It has to be D then. Please let me know if you have a question here. So basically what I've done is I've just made the next section of like how would it look after some time. So x has to go down. So the graph that represents the displacement here is D only, which shows x is going down. All others do not. Now, which statement about all types of transverse wave is correct? So transverse waves, they have the same speed. That's not correct. They have the vibrations parallel. That's not correct. They can all form stationary waves. I think they can all form stationary wave. Why not? Why not? Yes, they can form. They can all travel through vacuum. That's not correct. Water can't. Now, okay, the microwave hit metal screen P and reflected. The stationary wave is formed between S and P. Okay. The wavelength of microwave is much smaller than the distance between S and P. A detector Q is moves at slow constant speed from this. What happens to amplitude detector on the microphone? Whatever. Okay. So decreases steadily. That's not correct. It should increase because there will be like antinodes and nodes where it should decrease. So that's correct. It should not be the same or increasing steadily. So this is Fs. Stationary here's this. So this is F naught. So this is greater than Fs. So F naught is greater than Fs, which means the direction of the car should be moved towards the observer. So and it wants us to find the speed as well. Fine. So 494 equals to 440 times the speed of sound divided by times the speed of sound minus Vs. So what you get then? 440 times 340 divided by 494. So 340 minus Vs equals to 302.83. Okay. So 340 minus 302.83, that gives us 37. So it should be moving 37 directly towards the observer A. The electromagnetic wave has a wavelength of this picometer in vacuum. To which region the electromagnetic wave? So 138 pico is 10 raised to a minus 12. 1.38 gives me 10 raised to a minus 10. So it should be like, it's the wavelength, right? So it should be X-rays, right? Now, then this one, two pulses traveling opposite and their wavelengths are shown. So what will happen? Interesting. Let's talk about something like just a point. Let's say it was 4, right? This point, where will it be after like 3 seconds? So speed equals to distance over time. So 0.50 times 3, it would be 1.5 meters ahead. So 1.5 meters ahead would be 4 plus 1.5, 5.5. So it would look like basically I believe like this, okay? And now let's make the other one with a different color. So it is 8, and 8 minus 1.5 is 6.5. So it should be at 6.5. So at 8, it will be like this, this and this, okay? So it will overlap exactly like this, okay? So 26, the most probable answer, that is there will be constructive interference, which means the amplitude is going to increase. Now, then going to 27, the gap is slowly widened. Which change occur if occurred theta the wavelength of emerging waves? By the way, it doesn't really affect the wavelength. The reason behind this is because basically the frequency is not changing, the speed is not changing, so it should remain the same, but the curvature should decrease, which means that it would be flattened out, a bit more flattened out, which means that this decreases. So A has to be the correct answer. Then a light wave of 720 laser X incident anomaly or diffraction grating. A diffraction pattern is observed. Light from laser Y is also incident anomaly on the same diffraction. Third order of maximum due to Y is seen at the same place as second order maximum. What is the wavelength? So basically you use n1 lambda 1 equals to n2 lambda 2. So that was X was, sorry, let me say, second order maxima due to lasers. So this is 2 and this is 720, and this is third order, and that's lambda 2. So 2 times 720 divided by 3 is 480 actually. Has to be A then. So monochromatic light of frequency f is incident diffraction gradient on line spacing d. The speed of light is c. Which expression can be used to determine the highest order maximum produced? So highest order of maxima produced is when sine theta is taken, where in sine theta, theta is taken as 90 degrees. So d sine theta equals to n lambda. D, if you put 90 here, then basically sine 90, by the way, if you don't know, is 1. So d equals to n lambda. Now in this particular question, there is no lambda. So lambda can be replaced by a speed over frequency. Is there an answer like what is d here? Grating, okay, line spacing. So n needs to be the subject in all of these. So d times f upon c. D times f upon c is basically p. This is pretty easy, not too hard. All right, now the next one. Electron moves clockwise around the circuit. Yes, we know. What statement about the metal plate is correct? So here you might see the area is more, and here area is decreasing like steadily. So I equals to NAVE. So we are talking about the drift speed and NAE. So area and drift speed are inversely proportional. Okay. So when the area is reducing, the drift speed should be increasing actually. So somewhere about that we should look at the answer. The average drift speed of conduction electron decreases. That's wrong. The average speed of conduction electrons increases as they move from right to left. That's correct. The number density of conduction, that's not correct. Because number density depends on the material itself. So if the material is same, so it will also be the same. The number of density of conduction electron increases. That's wrong. It doesn't change really. All right, water time. Okay. Now diagram shows the direction of current in the metal block. The charge carriers enter through PQRS and leave the block through the opposite phase. The number of density of charge is n. Each charge carrier is z. The average disk speed is v. What is the expression gives the current in the block? So this is the area, right? So area can be found out by y into x. Interesting. I equals to NAVE. We want to find the current. Area is yx, sorry, n times yx VE. And Vixie. And Vixie should be the correct answer. Okay. What could not be used as unit of potential difference? Potential difference is basically joules per coulomb. So what to do then? Joules per coulomb. And we have to find something like this. What is this? Newton per meter. Newton per meter. Force over distance. Joules is not force over distance. Force times displacement, right? Because it's work done. So that's incorrect. 100% incorrect. This is watt over current. That's correct. So this is power over current is voltage. This is power over resistance under root is voltage. That's correct, because power is V square over R, right? And this is current into resistance is voltage. That's correct as well. Now, which could not show how the resistance of filament lamp varies with applied potential as V is increased to normal potential difference. The change, either the resistance can stay constant, the resistance can increase non-linearly or decrease non-linearly. This is basically thermistor, this is fixed resistor, and this is filament. But the thing is that it would never ever be like this. There is no linear change. It basically filament lamp does not follow Ohm's law, and that's why it can follow Ohm's law if it's the temperature remains constant, but the change cannot be linear at all. The reason is that the current will continue to change. That's why it has to be A then. Alright, if you have any questions, please let me know. Right. Kirchhoff's two laws of electric circuits can be derived by using conservation laws. On which conservation laws Kirchhoff's law depend? Kirchhoff's first law and second law. First law depends on charge conservation and second law depends on energy conservation. So that's to be B then. Which statement about the circuit is not correct? Okay. EMF, electromotive force, is the energy transferred per unit charge. That's correct. Energy is transferred from chemical potential energy in the cell to other forms when switch is closed. Well, that is correct. It goes to electrical for sure. Okay, then the electromotive force of cell is greater than terminal potential. That's always the case because there is internal resistance. When is the switch open? The voltmeter measures EMF of the cell. That's wrong. This will measure terminal potential actually. Which equation relating to voltmeter readings are correct? So V1 will be equal to V2 because they are in parallel. However, these two will be equal to V3 plus V4. Is there an answer like that? V2, what is this? What is this? V2 equals to V3 plus V4. So V2 minus V3 minus V4 should be 0. That's correct. That's correct actually. This is not correct. V1, V2, and V4. That's not correct. Okay, fine. Now, a network consists of this and this. The potential difference across the network is 4. Across the network, what is the current through 3 ohm? Very easy. So what you do, you want to find the voltage across this one first. So you can use potential divider here. This whole, you can find the resistance in the parallel. The resistance parallel will be 1 by 3 plus 1 by 6. So 6, 2, 1 equals 1 upon R. So R will be 6 over 3, that is 2. So 2 ohms is this. So 2 divided by 6 plus 2 times the total EMF will give you the voltage here. So that's potential divider equation if you don't know. Divided by, multiply by 4, that's 1 volt. So this is going to get 1 volt and V is equal to IR. This gets 1 volt, this also gets 1 volt because they're in parallel. So 1 volt, current and 3. So 1 by 3 is the answer. And let's see what is that. 0.333. Okay, C. Okay. The reading in A1 is 0.6. And they're all identical resistors. What are the readings on other ammeters? Let's take it 2 ohms, 2 ohms, 2 ohms. It's a tip that you should always take them as 2 ohms. The reason is one sometimes gives you the wrong answer. So now you could actually think like this. If this network has 4 ohms, 4 ohms gives you 0.6 ampere. Okay, so 2 ohm will give you basically double the current, which is 1.2 ampere. Why am I multiplying it? Because it is a inverse proportion. Resistance is inversely proportional to current. So if you have if you have half the resistance, then you get double the current. That's how I'm doing it. And this is like 6. So if you have like interesting. So you can do it like this. 4 times 0.6 equals to 6 times x. So 4 times 0.6 divided by 6 is 0.4. So this will get 0.4. Now this branch, and this branch in parallel. So all together, this current is A1, this is A3, this is A4, and we want to find A2. A2 will be sum of these currents because it is coming out of the battery. So battery is supplying all of it. So that's 2.2 actually. So, oh, they didn't ask A1. That's not, oh, they didn't ask A, they did ask A2. So this is 2.2, 1.2, that's correct. Okay, pretty good. An unstable nucleus of element decays by emitting an alpha particle or beta particle to become a nucleus of a different. This nucleus is also unstable and emits an alpha particle or a beta particle. The process continues until an isotope original element is produced. What is the possible number of these particles emitted? So X, let's take oxygen or carbon. Carbon is my favorite. So if carbon goes into, let's say, X, and then it emits alpha particle, so this would be 8, this will be 4, and then if it emits beta particle, it will be 8 and 5. Then it should emit a beta particle again to create 6 here and 0 here. But the thing is, how would we make, so this is basically an isotope. So the iterations that there are, so there can be 3 iterations on this. So 3. Pretty good actually. Now the diagram shows the core composition of 4 different hadrons. One of the hadron is sigma positive. It is a charge plus, and where is the element? What could be the hadron? Sigma plus. So you have to see. So here it will be minus 1 by 3, minus 1 by 3, minus 1 by 3. So minus E. We want positive. This will be minus E as well. This will be plus 2 by 3, minus 1 by 3, minus 1 by 3, 0. This will be plus 2 by 3, plus 2 by 3, minus 1 by 3, that is plus 1. So that has to be T. Wow, this took like 50 minutes. Very good. Alright, you guys have any questions? Please let me know.
So next paper.
Okay, so the next paper is October-November 2019, paper 1-2. No, sorry, paper 1-3. That should be the next paper. Okay. Now, tomorrow, basically, I cannot take class before, after. Let me think about it. 11 to 12, 12. So 12 to 1 p.m. Pakistan time. That is tomorrow's class. Okay. Let me write it down for you guys too. Don't forget about it. Wait a second. Where are you people? So
this is the only time you'll be free?
yeah, only time I'm free. Tomorrow I can't.
Alright.
Because
And then after tomorrow?
after tomorrow, same time is fine. October,
11
November
p.m.
2019. Because that's just one day, right? So I can manage.
Yeah,
that. 2019 paper 1-3 tomorrow. Okay. And time is 12 p.m. Pakistan time. Okay, perfect. All right. I will see you people in the next class then. Bye.
Alright, so
Allah
Bye.
Hafiz.
Sir,
Yes.
I don't